paper 6, question number 1. You are given there, sketch the graphs of y equals 2 mod x plus 1 and y equals 2 minus mod x. That two graphs you have to sketch. Okay. So first graph, y equals 2 times mod x plus 1. Right. First, when we define the mod x plus 1, mod x plus 1 function will take different functions at x equals minus 1. How do you get this minus 1? X plus 1 when we equate to 0, x is minus 1. Then mod x plus 1 will take the same function x plus 1 at minus 1 and on the right of minus 1. Left of minus 1, mod x plus 1 will take minus of this. That means multiply this by minus sign. Then we get minus x minus 1. Then first thing is x greater than or equal to minus 1. Y equals 2 times mod x plus 1 graph will take y equals 2 times mod x plus 1. On the right of minus 1 is x plus 1. This way. Then we get 2x plus 2. Y equals 2x plus 2. At in the left of the minus 1, y equals 2 times mod x plus 1. Graph will take 2 times on the left of minus 1, minus x minus 1 is therefore minus 2x minus 2. Okay, right. Now we can sketch the graph. First, this and this both we have to sketch. I'll take the axis like this, y-axis, and this is x-axis. Right. Okay. To draw this straight line, we need to find the one point. This one put here. Then we get x coordinate is minus 1. When I put minus 1 here, minus 2 plus 2, 0. 1 point is minus 1, 0. Minus 1, 0 point is suppose here. Right. And this is drawn on the right of minus 1. No? Then another point we need to draw this line. As that point I can take the intercept. Intercept 2. Intercept 2 means when x equals 0, y is 2. Right. Suppose here x equals 0, y is 2 is here. Right. This is 1, right, y2 here. Then the graph, this we can draw this way. This is the point 2 now. Join these two. Draw this way. Right. Another graph we have. It is this. Here also we need 2 points to draw this line. Put x equals minus 1 here. When x equals minus 1, y 0. Again this point. And another point we need to draw. As that point I can take the intercept. Intercept is minus 2. Same depth we have to take. This is 1. Right here. Minus 2. Right. This side. And this side is minus 2. Then this line pass through the point this and this. The whole line we can draw by producing to both things. But we don't need the whole line. We need only the part on the left of minus 1. Right. So then that we can easily take. Join this and this by a dotted line. This way we can produce it. This way we can produce it. Okay. So this dotted line we draw here to say, to draw this line, we use this point and this point. And since we need the line on the left of minus 1, this dotted line we produce this way, right? Okay, so now this is the line, this, the equation of that on the left of minus 1, no? Y equals minus 2x minus 2, and this one, y equals 2x plus 2, no? 2x plus 2. Y equals 2x plus 2. Right. This next graph we need to draw. People, y equals 2 minus mod x. Y equals 2 minus mod x. Right. So then mod x we can define. That changes at 0. Mod x 0, and on the right of 0, mod x will take x. 0 on the left of 0, mod x will take minus x. Then first one, when x less than 0 range, when we find this, y equals 2 minus mod x, on the left of 0 is minus x, no? Then we get y equals 2 plus x. Secondly, x greater than equal 0 range, right? Y equals 2 minus x coming, no? Y equals 2 minus x. Now, this line and this line we have draw, right? So there also, this x equals 0 we have to put here to find one point, x equals 0, y2. Here also, when you put x equals 0, y2, 0.2 is 1 point, right? And another point we need, I'll put here x minus 2. When you put x minus 2, y we get 0. Then 1 point is 0, 2. That means this point. Other point is minus 2, 0. Minus 2, 0 is here, right? Minus 2, 0 point is here now. So then that graph passes through this point and this point. So we can now draw it like this. Join this and this points this way. Produce to this end, because that graph we need to draw on the left of 0. And similarly, second one, another point we can put here. One point is 0, 2. Other point we can take, put x equals 2 here. Y 0, 2, 0. Right, so then the same length we can take, no? Approximately here, right? 2, 0. Okay. Then this next graph I can draw like this, Okay. Right. So then, if I take only this branch, its equation is y 2 minus x. This one y 2 plus x. Right. Now the single equation for this red graph is this. The single equation for the black graph is this. Okay. Now I will take this point as a. I am going to find the x coordinate of this a. That means this value. To get that, we can solve this equation and this equation, right? Okay. Then point A we can find. Point A. Point A x coordinate I supposed to find here now. Point A you can write. Right, solving. Yeah, y equals 2 plus 6 and y equals minus 2x minus 2. So equate this right hand side, 2 plus 6 minus 2x minus 2. this side, 3x minus 4, x equals minus 4 by 3. Right? This x coordinate is minus 4 by 3. Correct, no? Right. Now what is asking next? The next part asking is, okay, hence or otherwise find all real values of x satisfying the inequality this. Right. Hence or otherwise. Hence part is easier. Don't go to other. Let's see how to take this. Now people, we are given to solve the next part of the question as this. Yeah, 2 times mod x plus 2 plus mod x less than or equal to 4. Okay? Right. Now, what I do there, I use a substitution for x as 2u. Substitute for every x 2u. 2 times 2u plus 2 mod 2u less than or equal to 4. Right, you can take this 2 out because that 2 is positive, no? From the modulus you can take out. This 2 into that 2, then this will be u plus 1. Here also you can take this 2 out, mod u less than 4. This 2 you can cancel out. Then we get by this 2 times mod u plus 1 plus mod u less than or equal to 2. This way we get. Okay. Then the given inequality to solve, we can convert to this way by using the substitution x equals to u. Now people, I can take this mod u to right hand side. Then we get something like this. Okay. Now suppose we draw this graph. Since here we have u letter there, when we draw this graph, our horizontal axis should be u. Vertical axis should be y. And here also this one, 2 minus mod u, we draw again on the same pair of axes. Horizontal axis is u, vertical is y. People, you can see, then only thing is that 2 graphs when you draw again, that 2 graphs will be coming in a plane like. Only thing is this x axis become u. Then of course, just thinking this one as our black one. Only thing is people, that x letter, right? X letter is now u. So therefore, this graph when we draw, right, it is nothing but this black one. This when we draw, that is really the red one. Then by using this one, we can answer. What is asking now? Asking is this. This graph should be less than or equal to this graph. That means the black graph should be below the red one. This is the black one. Black one should be below the red one. What is the range of u? Black one below the red one. You can see here, black one lies below the red one between the 2 x values minus 4 by 3 and 0. So therefore, by using these 2 graphs, now you can answer this. How? This happens when u between minus 4 by 3 and 0. Right? Then now I can answer it like this. I can answer it like this. By the graphs, this happens. By the graphs, this happens when u greater than or equal to minus 4 by 3 less than or equal to 0. Because here we have equal sign also. Then this and this both are equal also we have to consider. Right. But really people, our question given us in terms of x, no? Then that u we have to convert to x. Then for the place of u, I put people what? That substitution is x equals 2 u, no? When subject to x by 2, put the x by 2. Right. Now, multiply this by 2. Plus 2. When you multiply, we get what? Minus 8 by 3, x less than 0. So, this is the answer for the graph this. For the inner part of this. Understand? Right? That is how we take the first one. Right. Second one, the limit part. The limit part we can take now. It is tan 2x minus tan x. Limit x going to 0, tan 2x minus sin 2x divided by x squared 1 plus x root minus root 1 minus x. Right. Okay. Now we can write this one. This tan 2x we can write as tan means sin by cos. Sin 2x divided by cos 2x. That sin 2x we take from here and here out. Then we get 1 over cos 2x here minus 1. Right. And by the conjugate of this we multiply numerator and denominator both. Conjugate of this mean changes this to plus sign, we get that, no? Right. So here we get minus, by plus sign we multiply, right? By the same conjugate we multiply the numerator. 1 plus x root plus 1 minus x root. This way, right? Right. Now here, this is a minus b into a plus b. That you can write as a squared minus b squared. Here I can take this cos 2x as the common denominator. 1 minus cos 2x come in. Limit x going to 0. Limit x going to 0. Sin 2x. 1 minus cos 2x divided by 2 I write here. And this x squared also here we have a minus b a plus b is a squared minus b squared 1 plus x minus 1 minus x. And here we have root 1 plus 6 root 1 minus 6. Now here this 1 and minus 1 you can cancel down. Here we get 2x. Right. Now this cos 2x I write 1 minus here. This cos 2x I can write as 1 minus 2 sin squared x. We have no. Then we can simplify. When you write this cos 2x as 1 minus 2 sin squared x, by removing this minus sign, this 1 and this we can cancel down. This 2 we can cancel down. Minus minus plus come in, no? Right. Then we have this a sin 2x. Here 2 sin squared x. Okay? Right. Here 1 plus x root, 1 minus x root. Here we get people minus minus plus, no? 2x. Right. Then here the 2x we get, I write where here. And this x squared, I write this cos 2x, I write where here. Okay, no? Now limit going to 0. Right. Now you can see here. Here x point 0 means this is of the form sin theta by theta. X point 0 means 2x point 0, no? So therefore this is 1. Here sin squared of x squared. X point 0 means this is also 1 squared. Here when you put x equals 0, here root 1, here root 1, they are 2. Here when you put x equals 0, cos 0 is 1. Understand? Then we get, right? We have to apply the limit for this one and this one, right? Limit x point 0. And here also we have to apply limit x point 0. Right. Then this is 1 into 2 times 1 squared into here 1 plus 1, 2 divided by 1. Then the answer comes as 4. Right? I mean as 4. Third one. Third one given as this way. Show that the equation of the tangent line to the rectangular hyperbola parametrically given by x equals ct and y equals c upon t. Third. Right, x equals ct, y equals c over t. Right, people here, when I multiply this x and y, we get ct and c over t. We can cancel down this 2. xy equals c squared. Xy equals c squared is called as a hyperbola. Right? Its graph is this way. Graph of the hyperbola is this. Okay. Then at any point on this graph, x coordinate is given by ct, y coordinate is given by c over t. Right now, we have a point P here. Its x coordinate given as Cp, y coordinate c over p. That means the parameter value corresponding to the point P is P, simple P. Here a tangent is drawn. Now asking the equation of this tangent. That equation of the tangent, we can write people. First we'll find the gradient of this. Gradient means dy by dx. That means we have to differentiate this. Xy equals c squared. C is a constant there, remember. Xy product we differentiate using u into v form. X we keep, differentiate y, dy by dx. Y we keep, differentiate x, 1. C squared is constant, 0. Then we get dy by dx minus y upon x. Now we need this dy by dx at the point P, no? At the point P only we need this dy by dx. At the point P, you know, the coordinates we have x coordinate Cp, y coordinate c upon p. Y coordinate C upon P, x coordinate CP. Okay. Then we get what? Minus P comes here, Cn, this C we can cancel down, 1 over P square. Okay. We get 1 over P square with minus sign. Now the equation asking of the tangent, no? Equation we can find of the tangent by using this. Y minus y naught equals gradient times x minus x naught. Using this we can find the equation of the tangent. There m is that minus 1 over P squared, x naught, y naught are this and this. Right? Then y minus y naught means C over P. Gradient means 1 over P squared. X minus x naught means Cp. Multiply this by P squared. Then we get what? P squared by, okay, plus 6 and P squared by, right. So now when you multiply this by P squared, we get minus PC. This one plus PC, take this minus PC to right hand side, another plus PC, PC, another PC, 2 PC, right? When I multiply this by P squared, we get minus 6, take that to left hand side. Then we get P squared y plus x plus 2 CP. P squared y plus x equals 2 CP is the equation. Next one asking the normal line to this hyperbola at P, normal line. Normal line means what? Perpendicular, no? Normal line is a perpendicular at the point P to this hyperbola. We draw a normal like this, perpendicular line like this. That cuts the hyperbola at a point Q, no? This is a point Q. Its coordinates given CQ, comma C over Q, like this. Then ask him to show this. But people, now you know the gradient of this tangent, just now we found minus 1 over P squared, no? This red line is perpendicular to this black. Then the gradient of red one going to be the reciprocal of this sign multiplied by minus sign. We get P squared. Is the gradient of this red line. Now the gradient of red line you can find in another way. How? You can find it by using the coordinates of P and Q. How? Difference of y coordinates divided by difference of x coordinates. The same gradient we can find. Okay? Then see what happens. Then what happens is, right, that gradient I can write difference of y coordinates C over P minus C over Q divided by difference of x coordinates Cp minus Cq. That gradient is equal to P square. This way. Okay. Right, now you can write here, take this C out, Q comes here, P comes here, Q minus P, and here PQ product. Take the C out from the denominator. This is P minus Q. This is equal to P square. C and C you can cancel down. This Q minus P and P minus Q we can cancel down. We get minus 1 here. Now minus 1 here. Use the cross multiplication. We get what? P cube. P into P square is P cube. P cube into Q equals minus 1. So this is the answer. P cube Q equals minus 1, right? Right. That is over. Now next one, number 4. We are given Okay, our next one is A0 minus 1, B 9, 8. Hmm? The point C lies on AB such that ACCB 1 is to 2. ACCB 1 is to 2. Right. Number 4. Right? So this way we have point A 0 minus 1. Point B 9, 8. Point C on the line AB divides internally in the ratio 1 is to 2. Let's assume the C as x bar, y bar, the coordinates. Huh? Then asking what? So that the equation of the straight line L through C perpendicular to AB. Right. First we'll find point C. Right. By using the ratio theorem, right, you can find x and y coordinates of the point C. How to find x bar? This side ratio 1 into other side x coordinate. 1 into 9, 9. Plus. This side ratio figure into this side x coordinate. 2 into 0, 0. Divided by 1 plus 2, sum of the ratios 3. X bar is 3. Now, y bar. How to write that? 1 into other side y coordinate 8. 2 into this side y coordinate minus 2. Divided by sum of the ratios 3. 8 minus 2 by 3. 6 by 3, 2, no? Y bar 2. Therefore, point C we can write x coordinate 3, y coordinate 2. C 3, 2 here. Secondly, people will write the gradient of AB. Gradient of AB. What is gradient of AB? Right. Difference of y coordinates 8 minus 1 is 9 divided by 9 minus 0, 9. Then gradient of AB equal 1. Okay, no? Gradient of AB is 1. Right. Now, we need the line that is passing through the point C perpendicular to this AB, no? Right. This is that line, suppose. This line L. Okay. Asking to find the equation of the straight line passing through C perpendicular to AB. Right. So now this line AB gradient is 1. This line L is perpendicular to AB, no? Then the perpendicular line, its gradient can be found taking the reciprocal of this end multiplied by minus sign. Minus. Now we know the gradient of this line and a point on the line. So then equation of L we can now find by using y minus y naught equals gradient times x minus x naught, right? Therefore equation of L. Equation of L, y minus y naught gradient times x minus x naught. Right. Y minus y naught is the y coordinate of the point C. 2. Gradient is minus 1, x minus 3. So simplify this, bring this to this side, y plus x minus 5 equals 0. That means x plus y minus 5, no? This we can write as x plus y equals 0, right? This way we get that. Huh? Now next one asking, let D be the point on L such that AD is parallel. Alright. D is a point on the line L. Right. I'll take D here. Right. Now D is a point on the line L, so that AD when we join. That AD line given parallel to the line y equals 5x plus 1. Right. Then asking to find the coordinates of D. Right. People, you know this line L. Its equation we found just now, x plus y minus 5 equals 0. It says when I consider any point on this line, if its x coordinate of the point is x, y coordinate is y, then this x and y coordinates always behave how? X coordinate plus y coordinate minus y is always equal to 0. Right. That means since D also a point on the same line, if I take D has the x coordinate as alpha, then y coordinate of D can be found how? Put that alpha x coordinate of D here, take in that and this minus 5 right hand side, you get y coordinate of D. What is that? Alpha minus 5. Take to right, 5 minus alpha. 5 minus alpha. 5 minus alpha is the y coordinate of D. Understood? Now, if we can find this alpha, then we can find D. Alpha can be found like this. This line and this line parallel. When the two lines are parallel, gradients are equal. Now, the gradient of this line we can find by using the coordinates of this 2 and this 2. Then, we can take the alpha, thereby we can find people this point D. Okay? Right. Then, I can write it like this. Okay? The gradient. By this, I subtract this x coordinate, right? Y coordinate. Y minus alpha. From that, I subtract a y coordinate. Minus 1. Alpha minus 0. Alpha. That should be equal to here the gradient 5. Then here we get minus minus plus 1, 6 minus alpha equals 5 alpha. Using cross multiplication, takes this side, 6 alpha equals 6, alpha equals 1. If alpha equals 1, now you can write D. Therefore, the point D, you can write how people? Alpha 1, no? X coordinate 1, y coordinate 4. Putting here 1. That way we can take point D. Okay. Next one. Question number 5. Right, question number 5 says x plus 2 cos squared x plus 2 root 3 sin x cos 6 minus 1 in the form r cos 2x minus alpha, where r positive and alpha between 0 and 9. Okay? Right. Now, we can take it like this. 2 cos squared x 2 cos squared x plus 2 root 3 sin x cos 6 minus 1. Right, people, this cos squared x, I can replace this way. We know cos 2x as a formula 2 cos squared x minus 1. Once we take this side, we get 2 cos squared x as 1 plus cos 2x. This one we can write 1 plus cos 2x. Here is root 3. I keep away. Then 2 sin x cos x is sin 2x. minus 1. This way we can write. Huh? Now, people, you can see this 1 and minus 1 you can cancel down. Now, here cos 2x coefficient 1, right? Cos 2x coefficient is 1, we square that. Sin 2x coefficient is root 3, that will also be square. Now we add and we take root, we get 2 here. Then what we do is, people, this expression now we have, we multiply by 2, meantime divide by 2. This one change, no? This expression we multiply by 2, meantime divide by 2. It won't change. It won't change. Right now? And now you can see here, this half you can write cos 60 pi by 3. Root 3 by 2 you can write sin 60, sin pi by 3, like this. Then you have with bracket cos A cos B plus sin A sin B. That is cos A minus B. 2 cos 2x minus pi by 3. Then you can compare this with the given r cos 2x minus alpha. Then r should be 2, alpha should be pi by 3. Right? We get this. Okay. Now, what is asking next, people? Asking next, hence solve this equation, right? Cos squared x plus root 3 sin x cos x equal to 1. All right. First time multiply this by 2. Then we get 2 cos squared x plus 2 root 3 sin x cos x equals 2. This 2 I can write 1 plus 1. Take 1 out, not out, left hand side. 2 cos squared x plus 2 root 3 sin x cos x minus 1 equals 1. Okay. But people, this one, only now we have here. But we have put this thing, this expression we can write like this. Then this place I can write, substituting that 2 cos 2x minus pi by 3 equals 1. Right? Now, bring this 2 we are here. Half. This half we can write as cos pi by 3. Left hand side also we have cos. Now cos equality. How to add the general solution? Yeah, now you know. Know how to add the general solution. Yes, how to add general solution? Left hand side angle 2x minus pi by 3 is equal to 2 and pi plus or minus right hand side angle pi by 3. Take this pi by 3 to right hand side. 2 and pi plus or minus pi by 3 plus pi by 3. Divide by 2 to subject x. In pi plus or minus pi by 6 plus pi by 6 in this any integral. This way we can write the general solution. We can write the solution this way. Right. Next question, number 6. Question number 6. A particle P of mass simple m and a particle Q of mass 2m moving on a smooth horizontal table along the same straight line towards each other with speeds for u and u respectively. Collide directly. The coefficient of restitution between P and Q is 4 by 5. Right? Show that the particles P and Q move away from each other after the collision. Find the time taken after the collision for P and Q to be a distance simple a apart. Right. Now, we can draw the diagram there. Here. Before the collision, P and Q. P here, Q here, mass m, 2m, this moves with 4u, this moves with u. Right, after the collision, I'm taking P and Q are moving in opposite directions. This way, this V2, this way, this V1, here M, 2M, P and Q. Right? We take this way now. The first question is, yes, the first question is, show that the particles P and Q move away from each other after the collision, right? That means we have to show this V1 and V2 are positive values, right? When V1 and V2 are positive values, then the particles move in the directions of V1 and V2, then they are going away, no? And they move away from each other. Okay. Now we can apply for the first thing, conservation of linear momentum after the impact momentum is equal to before impact momentum. We apply that right word. 2m v2 minus mv1 is equal to 4mu minus 2mu. M. We can cancel down. This way we get 4u minus 2u is 2u, number 1. Right? Now we write Newton's law of restitution, that also we apply right word. That says minus E. E is here 4 by 5. Right? Minus E, relative velocity before impact. Right? Relative velocity before impact. We'll stop Q. Apply U here. To find the relative velocity, relative to Q only, I supposed to find the velocity of P. Right? We put U here, and the same U you have applied, we have to apply on this P. Right? To stop this Q, velocity of Q, it's U, no? Applied right word. The same U we apply. This will be phi U. Right? Right, equal to relative velocity after impact. After impact. After impact also, people, we have to stop this Q, because before impact also we stop Q, no? Right, apply V2 this way and V2 this way. Then this P will be getting V1 plus V2 leftward. But we apply NLR rightward, no? Then that will be minus V1 plus V2. Minus signs we can cancel down. This and this we can cancel down. V1 plus V2 is equal to 4U, number 2. Right, now at this 1 and 2, by adding 1 and 2, minus V1 plus V1, we can cancel down. 2V2 plus V2, 3V2 equals 6U. Then V2 equals 2U. V2 equals 2U. If v2 equals 2u, v1 also 2u by 2, v1 also 2u. Now you can write, since v1, v2 both positive, right? v1 comma v2 both positive, the spheres move after impact away from each other. Away from each other, right? Okay. Now find the time taken after the collision for P and Q to be a distance simple a apart. All right. Now people, after the collision, soon after the collision, now this is how they begin to move. No? This P moves leftward v1, Q rightward v2. No? Right. Now I consider the motion of Q, velocity of Q relative to P. Velocity of Q relative to P. Relative to P means we have to stop P. How? Apply the velocity of P, v1 in the opposite direction to stop that. That added velocity we have to apply on this Q also now. Then present situation is P at rest, because v1 leftward, v1 rightward, P at rest. Q got v2 plus v1. Then that velocity we defined as velocity of Q relative to P. Velocity of Q relative to P is now v1 plus v2. Right. Now the situation is this, people. Now Q at rest, P at rest, not Q. P at rest, here P, rest. Now Q going away from P with velocity v1 plus v2. Then asking the time it takes to go away a distance simple a from P. Now we can apply S equals ut. Right, velocity is v1 plus v2, distance a, then the time going to be distance divided by velocity. S equals ut, no? Right, therefore the time. Time is a divided by v1 plus v2. At a, given v1 plus v2 is for u. Here, for u. A over for u. Is the people is time. Right, now question number 7 given are this way. Right. This relative acceleration question there. See here, particle Q is here. Right, here we have mass 3m, here 2m. This is 2m, right? Right. This is mass m r p. The forces acting on this normal reaction coming are, that is perpendicular to plane. This way. Right. Now here I take the tension in the spring as T1. Here it is T1 the same. Here also T1. Here T1. In the spring T2. Everywhere along the spring T2. Right, this way. 3 mg weight. 2 mg weight. Right, now we can take the acceleration of this 3m is going down, 2m going up. Then this direction I take the acceleration as f2. This acceleration f2 is relative to this q. That means suppose a fly is on the pulley q. That fly sees this 3m is going down with acceleration f2. Right. So then this end 2m should move upwards with acceleration f2 because the spring is inextensible. Then this fly on the pulley q notices 3m moving downward with acceleration f2, 2m moving upward. Right. Now this pulley q also, people, moving down. Then I'll take its acceleration as f1. This acceleration f1 is acceleration of this pulley q relative to earth. That means suppose another fly is on the pulley A. It sees the q moving downward with acceleration f1. Okay. Now this p should also be moving this direction with acceleration f1 because this end and this end of the spring, the acceleration must be equal. That's the reason. Okay. That's the reason. Right. Now, people, you know, when a certain person, right, observes the motion of this 3m, you can see, now suppose this 3m is stationary, doesn't move. Now q moving down with acceleration f1. Since this q moving down with acceleration f1, because of the motion of this q, this 3m should also be moving with the same acceleration f1. That means, people, now suppose when you move in the bus, right, you are sitting on the bus. Bus is moving with certain acceleration. Then you get automatically that acceleration. Now while the bus is moving this direction, now you stand up and move this way forward with another acceleration f1. Then a person on the earth notices your acceleration is as f plus f1. Like that, this 3m suppose doesn't move. Since this q is moving down, the acceleration of q automatically comes to what? This 3m. Okay. Right. Meantime, if this 3m moves with another acceleration as you moved in the bus forward with certain acceleration, this person in the earth notices the acceleration of this 3m going to be f1 plus f2 downward. That is how an observer in the earth notices about the motion of 3m. That acceleration is called as the acceleration of 3m relative to what? Earth. Then it is written how? F stands for acceleration. Acceleration of 3m relative to earth. It is downward direction, f1 plus f2. Right? Same time, people, this q moving down with acceleration f1, this 2m moving up. Now suppose in that bus, while the bus is moving forward, from the front you move back with acceleration f1. Then the observer in the earth notices your acceleration. You have acceleration because of the move in the bus f rightward. Meantime, inside the bus you come to the leftward. Then the person on the earth notices, right? You will have resultant acceleration. If you take this direction, it is f1 minus f. This direction, f minus f1. Like that here, people, I can consider this q brings this 2m downward with acceleration f1. Meantime, right, this 2m goes with acceleration f2. So therefore, acceleration of this 2m relative to earth, if I take upwards direction, f2 minus f1, right? f2 minus f1. right? This way we can write the accelerations relative to Earth. Okay, right. Now we can write F equals ma. We can write F equals ma, right? Apply F equals ma. Number 1 for P, rightward. It is P1 equals mf1, number 1. Number 2, for Q we can apply downward. We are given Q as light pulley. Yeah, T2, T2, 2T2 minus T1, right? 2T2 downward minus T1 equals mass of the Q 0, right? Light, light pulley given, light pulley. Then we get 2T2 minus T1 equals 0. Number 2. Number 3, we can write next one, people, for this 3m particle, we apply downward. What is that? Force is 3mg, other direction T2, 3mg minus T2. 3m minus T2 equals 3m. Remember, in F equals ma, the a is the acceleration relative to Earth. Then this acceleration only we have to put there. F1 plus F2. Number 3. And the other one we apply for this 2m. For 2m, both 1. For 2m we put upwards. T2 minus 2mg equals 2m. Its acceleration relative to Earth here. F2 minus F1. This is number 4. People now asking to find what? Asking to find obtain equation sufficient to determine the acceleration of Q. So there are how many unknowns, people? T1, T2, 2 unknowns, F1, F2, other 2, altogether 4. 4 unknowns are there, 4 equations are there. We can find. Right? Sufficient equations we have written in. Right. That is that question. Right. Next question, number 8. Number 8. Question number 8. Vector question. In the usual notation, the position vectors of 2 points A and B with respect to a fixed origin O are 2i minus 3j and I minus 2j respectively. Using AO vector dot AB vector, find OAB angle, right? Find OAB angle. Okay. Okay, now we can write this. X axis, unit vector is I. Here, positive y axis, unit vector is j. We are given the position vectors of 2 points. Point A, 2i minus 3j. 2i minus 3j. X coordinate 2, y coordinate minus 3. A. And B, I minus 2j. 1 minus 2. This way. I minus 2j. This way we have the 2 points. I minus 2j, 2i minus 3j. Right. Is the point A. Position vector is 2i minus 3j. Point B is. Okay. Now, asking what? Considering AO dot AB, find OAB. O is the origin. OA vector 2y minus 3j. OA vector mod 8 people. Square root of coefficient squared plus j coefficient squared. Here 9 for 13. Right. Secondly, OB vector. OB vector is I minus 2j. Then OB vector modulus how to take people? Square root of I coefficient squared plus j coefficient squared. This is root 5. Right. Now people, we need AB vector to take the dot product. AB vector we need. AO vector and AB vector. Right. We have taken the dot product. AO vector minus OA. No. AO vector means minus OA. Then AO vector is minus OA vector. Here. Multiply this by minus sign 3j. This. Secondly, we need AB vector. AB vector. Right, people, how to write AB vector? AB vector mean here second letter position vector minus first letter position vector. Second letter is B, no? It's position vector I minus 2j. First letter A, 2i minus 3j. Here minus 2i, here I minus 2i is minus I. Here 3j, 2j, it's j. Then AB vector, we have its modulus, I coefficient perfect squared, j coefficient perfect squared root. This is root 2. Right, no? Now we need to consider AO dot AB. Right. AO vector mean this people. A to O vector this. A to B vector this. Then the angle between them only we need to write the dot product. What is that? AO modulus into AB modulus into cos theta. AO modulus mean this A to O length, that is equal to O to A length. That means root 13. Right. This is root 13. AB modulus root 2 cos theta. Right. Left hand side AO vector. Here minus 2i plus 3j dot AB vector minus I plus j. Right. People, you know, when we take the dot product between two vectors which contain this I and j, we have to multiply I coefficients and j coefficients. Right. Minus 2 into minus 1, 2. 3 and 1, 3 equals root 13 root 2 cos theta. By this you can subject cos theta. Theta is equal to cos inverse what? Here 5, here root 26. 5 over root 26. We get the angle. Right now? Now, let C be the point on OA such that OC be pi by 2. OC be pi by 2. Right. OC be pi by 2. Here suppose we have point C. Right. OC be pi by 2. OC vector we are asked to find. OC vector is. Right. People, OC vector we can write as a part of OA vector. No? OC vector you can write as lambda OA. What is lambda? Real number. Then OC I can write lambda times OA vector 2i minus 3j. Right. OC vector, okay. Now, I write this people CB vector, C to B vector. How to write CB vector? CB vector you can write CO plus OB. Okay. C to B vector CO plus OB. Right. Then we can write CB vector like this. CO means minus OC. OC is this. Correct, no? This CO vector we can write as minus OC. Minus, this is your OC vector. Plus OB vector. OB vector given as I minus 2j. Right. Then I can write CB vector. Right. Take these I coefficients together. Here we get minus 2 lambda. I take I out. Plus 1 I. J coefficients. Here minus plus 3 lambda. Minus 2 J. This way we get. Right? Minus 2 lambda plus 1, 3 lambda minus 2. Okay. But people, since this angle is 90, OC vector dot CB, the dot product between the vectors OC and CB should be 0. Right? Then you can write, since OCB angle is pi by 2, OC vector dot CB should be equal to 0. Then by using this, we can find lambda. If you know this lambda, all right, you can take OC vector. Now, OC vector lambda times 2i minus 3j, no? 2i minus 3j. CB vector minus 2 lambda right OCB right people here I think very easily I can take the answer the CB vector we have right the CB vector perpendicular to the OA that's also correct no OC vector and CB also perpendicular OC CB this angle 90 no meantime we can say OA vector and CB vector also perpendicular so therefore I can take here OC dot CB dot product 0 that's correct for the place of this OC I can write OA reason OC line and OA line being the same if OC is perpendicular to CB OA also perpendicular to CB right then we can write OA vector dot CB right so then OA dot CB 0 then OA vector we know it is 2y minus 3j 2y minus 3 CB vector right people CB vector we know this minus 1 minus 2 lambda I plus 3 lambda minus 2j it should be 0 now I coefficient we can multiply 1 minus 2 lambda j coefficients we can multiply minus 3 lambda minus 2 equals 0 correct no now I can write okay simplifying this right here we get 2 and here 6 8 take to right hand side minus 8 here minus 9 lambda minus 4 lambda minus 13 lambda lambda equals 8 by 13 now we know lambda then we can find OC okay OC right therefore OC vector equals lambda means 8 by 13 2y minus 3j this is how we find the OC vector right question number 9 the next a uniform rod AB of length 8a and weight W has its end A smoothly hinged to a fixed point. One end of a light inaccessible string of length 4a is attached to the point C on the rod such that AC equals 3a. And the other end is attached to a fixed point D vertical above A such that AD 5a. The rod is in equilibrium so that the tension of the string is this much. Find the horizontal component of the reaction at A. Yes, that part. Right. Go to the diagram there. See, we have the rod. Right. Point D is vertical above A. This is D. String is this. C. We are given this length is 5A, people. This is A. A is at A. We have a hinge. A ceiling given as 3A. This is 3A. And this length given as 4A. Then these three lengths, 3A, 4A, 5A. Satisfy Pythagoras theorem. So therefore here it is 90. Right. The length of the rod is given as 8A. Here B. Right. Center of gravity should be midpoint. Here. Uniform rod, no? W here. This length is 4A. From here to here. Right. Tension T here. This way. D feels the tension T like this. The rod feels the tension T like this. Huh? Now, the reaction I can write in two components. Rightward X, upwards Y. Here 90. Right. Let us take this angle as people theta. Then it's sine plus tan you can write. Sine theta going to be what? Opposite side divided by the hypotenuse. 4A by 5A. A and A you can cancel down 4 by 5. Cos theta adjacent by the hypotenuse. 3A by 5A. 3 by 5. Now what is asking people? Asking the tension T. For the equilibrium, we can take moment around A. W gives clockwise moment. T gives anticlockwise moment. Right? For the equilibrium, take moment around A. Right? We will take anticlockwise. T multiplied by the force T perpendicular to the rod. Moment means force multiplied by the perpendicular distance. T into 3A. T into 3A. Equals W times the perpendicular distance from A to the line of action of W. The length this. Right. If this is 3A, if this is theta, this is also theta. Then the opposite side of theta only we need. 3A sine theta. 3A sine theta. W into 3A sine theta. Okay? People not 3A, sorry. 4A, no? The length from here to here, 4A. Because the whole rod is really 8A. Center of gravity is at the midpoint. This is 4A, not 3A. 4A. A and A you can cancel down. 3T, 4W, sine theta, 4 by 5. Then we get T, 16W over 15. That's correct. Also find the horizontal component of the reaction at T. Asking only the horizontal component. For the equilibrium of the rod, resolve forces horizontal rightward like this. We resolve the forces rightward. What are the forces acting horizontal rightward? X. Leftward force is this people here. This T, when you resolve this way, there is a leftward component. How to find that? You know, if this is theta, when we draw horizontal line like this, right, this is theta, then this is 90 minus theta. Here 90, then this is theta. Then T cos theta is a leftward component. T cos theta is equal to X. X equals T cos theta. Right. T 16W over 15 cos theta 3 over 5. Okay. Then we can cancel down here this and this. We get X 16W by 25 is the horizontal component. Right. The last question, people. Number 10. Also a corporate process question. It says uniform rod AB of length 2a and weight capital W is held in equilibrium by a light inextensible string BC and by a horizontal force P applied at the end A as shown in the figure. Given that the rod makes an angle 45 degrees with the horizontal, so that angle theta that the string BC makes with the horizontal is given by tan theta 2. Find the tension in the string in this position in terms of W. Right. Now here, this is the uniform rod, weight is W given, horizontal force P given like this. When we produce this line, this angle given as 45. Okay. At the end B, the string is joined, uniform rod, right. Right, people, now the tension T should act here. That tension T acts along the string, right, this way. Right, this point is B. We are given this angle theta. Okay. Now the rod AB. Rod AB is in equilibrium under the action of three forces. What are the forces? Weight W, force P, and tension T. You know, we have learned in corporal forces lesson, when any object is in equilibrium under the action of three forces, the three forces must meet in a point. So, if W and P meet here, definitely the line of action of the tension T in the string produced should pass to the point this. Okay, right. Now, people, the length given as 2a of the rod is a uniform one. Therefore, this is A, this is A. If this angle string makes with the horizontal theta, when you produce this way, this is also theta. Right. Now we are asked to find this tan theta. Tan theta can easily be found, people, like this. I am going to construct this way. Vertical line. This horizontal line. At this height, you can write. What is that height? You know, people, here to here, 2a. This is 45. Then this is 2a sine 45. This length, if I draw horizontal line here, this is 45 because this is 45. What is this length? A cos 45. A cos 45. Then tan theta we can write, opposite by the adjacent, right? Therefore, tan theta 2a sine 45 divided by a cos 45. Equal a and a you can cancel down. You know sine 45 and cos 45 equal 1 over root 2 each. Then that 2 also we can cancel down. Then we get tan theta as 2. Tan theta equals 2. Right. Now asking, find the tension in the string in terms of W. tension in the spring can be found, people, for this equilibrium of the rod. Rod is in equilibrium, no? We resolve forces upwards. Then what do we get? Here T sine theta upwards should be equal to W. For the equilibrium, now you can write. For the equilibrium resolving upwards, we can say T sine theta should be equal to W. Right. Sine theta you can find because tan theta we know 2. For a right angle triangle, tan theta means, here tan theta 2 means, tan theta means opposite side divided by the adjacent side. Opposite to adjacent 1. Then hypotenuse is going to be root 5, no? 2 squared plus 1 squared. 5, no? Its root. Sine you can write opposite by the hypotenuse. Equals W. Then T going to be root 5 W by 2. This way, get the tension T.